Hi. In the last videos, we have seen arrays, 1D array, 2D array. We have seen how to take inputs in these arrays, how to display the elements of these arrays. We have seen how to use these for loops to access through these elements of this array. So now we'll discuss about 3D array. So in 3D array, we need three dimensions. So we need three subscripts. So in 2D array, we have seen two subscripts. So now we'll see for 3D array, we need three subscripts. Let's suppose we say I, J, K. So I for first dimension, J for second dimension, and K for third dimension to access the elements of array. So let's see with the help of example, we'll see the program for it, and then we'll move on to another topic. Suppose here I have taken this array ARR with three dimensions. First is the number of elements, first dimension size is 4, second dimension size is 3, and third dimension size is 2. Okay, so now we want to take, suppose we want to take the input in this array. So we need to use this for loop three times. Okay, for three dimensions. So for the first dimension, I equal to 0 to less than 4, I plus plus or plus plus I, and then j for the second dimension. So j starts from 0 to less than 3, and for k is equal to 0 to less than 2. Okay, so we can have this much elements in our array. Okay, it depends on us. We can declare larger sizes also, and then we can take the lesser values also. We can ask from the user how many, what is your size of the elements of your array, and then we can take this input. So suppose we want this dimension only. So 4 rows, 3 columns, and each has 2 elements. Okay. So now with the help of this loop, we have inside this inner for loop, we are writing scanf %d ampersand array ij k. For two-dimensional, we have seen we need only two subscript array ij, and we did not need this one third inner loop. Okay, we didn't needed this loop, this one k for two dimension, but here we need it because it is of three dimension. Okay. After that, after taking input, we can print these values using again the same for loop. For I equal to 0, I less than 4, I plus plus, or j equal to 0, j less than 3, plus plus j, and k equal to 0, k less than 2, k plus plus. And then we are printing the value of array ijk. So here it is %d for ijkth value, and then the value of array ijk here. Okay, so don't get confused. This is for array aijk values. We have this one. Let me write with this. Right. Okay. This %d is for I, this %d for j, and this %d for k, and this %d for this value, array ijk. Let us run this program and we'll see how it is working. Okay, let us run this program. Now we save it. Now compile the current file. We'll see no errors. After that, we'll run this program, enter values. We have to enter values to this array. It will take that much. We have run the loop. It will ask the values for that much time. Now it is printing the values here. So you can see that it is printing the value using the another for loop. Okay. So let's suppose we have this. We can change this things also using this taking the values of ijk, maximum values of this ijk, asking from the user. Okay. So you can practice it and you will learn more. So you can find the address of any particular element using the name of the array, because the name of array is itself the address of the array base element or the first element. So the we can say that the name of the array is the base address of your element. Base address means the first element of your array. So if suppose this is an array, we have defined as array integer and we are defining its size as 4, and after that we are taking the number of taking the input using this for loop, and inside this we have used scanf, and after that I am printing this ARR, means we are printing what? We are printing the address of this first element of this array, because we are writing ARR. ARR is the base address, and base address is the first base address is the first address of the first element of the array. So when we compile it and run it, you will see it is compiled successfully. What I have written here for this address, we use this %p. Okay, so just remember that now it has been compiled, zero error and no warning. Now I'm running this. So suppose I'm entering the elements for this 5, 6, any values you can enter. Says taken 4. So 10, 4 values I have entered. Now it is showing base addresses 0061FF0C. So it is the address of the first element. Now suppose I want to print the address of the second element also. Then we can write this thing. So this is Control C. And this. Now see, when we want to print the address of second element, we just have to add the offset here, array +1. Offset is the index. So we add this number +1 here to get the address of second element. So see, when we compile it here, what happened? We compile. So zero error, zero warning. See what happened in the when we run it. Suppose this is the elements. So the base address is 0061FF0C, and the next base address of the second element is 0061FF10. So this is the first element, this is the second element. And so on you can write, like suppose here I am writing slash so that it can go in the third line. And then I want to print the array of address of third element. We just have to add the offset. For third element, the offset is what? Index number. So for that you have index number 2. So we add that 2. and address of PHI third element. Now save it and then compile. After compiling, then run. Base address is 0061FF0C and base address of second element is 0061FF10. Then base address of third. We can write the address of third element is 0061FF14. So this showing this way. Okay. Okay, let's just change this. Don't write base address here, just address. Zero zero, address of second element, address of third element, and so on. You can do this and you can find the address using this offset. So we can say that it is the array plus the offset. You can use array plus offset to find the address, and for this format specify we use %p. Okay, so remember this thing. Okay, thank you, thanks for watching. In the next video we'll see functions. Okay, bye.